the first release of the Linux version was 3 or 4 years ago, and currently it's under development. And each new version of Iber works both in Windows and Linux. SO. Okay.
Okay,
When I press
so
you the control, can you control the
yes, I
screen?
believe that. No, yes, I.
Yes, perfect.
Oh, sorry. Has some delay, some lag. You can go to the previous. Uh, mm, well, so thank you for the presentation of the team, David. I'm Esteban Sañudo. I'm a PhD working on University of A Coruña, and I'm part of the IBER team with Marcos. This first part of the presentation is a brief theoretical presentation in order to know how is the engine that works inside the IBERGIS. So first of all, I usually introduce numerical modeling, beginning from the natural processes. We are going to try to reproduce natural processes, for example, river flooding or pluvial flooding using mathematical equations, mathematical formulations that try to reproduce the behavior of these natural processes. Okay, once we have the mathematical equations, these equations usually are really complex and not easy to solve. So we translate or we approximate these equations to a numerical model that can computers understand. No? So we have the numerical model, and then we compute this numerical model inside computational systems to finally have a numerical simulation of the processes, for example, in this case, of a river flooding. We are developers of Iber. Iber is I don't know if you can see the next slide or not. For me, it's really, yeah, no. Iber is a two-dimensional model that the first release was in 2010, so we have more than 15 years of age, and it appears as a combination of tourbillon and carpa that was two different two different numerical models that consider the hydrodynamics, the turbulence, and the sediment transport in this first version. Then Iber continues adding capabilities, for example, the dam break, the water quality, the fluvial habitat, and two milestones that was really important were really important was the incorporation of the hydraulical processes with a new DHT scan, the possibility to add rasters of rainfall, and also the possibility to compute the infiltration using different infiltration models. And other milestone was in 2000 in the version 3.0, the inclusion of the drainage capability. So we can model pluvial flooding or hydraulical processes inside Iber. I now was focused in urban hydrology because it's the main topic of this presentation. As you can see, urban hydrology, as also David introduced, is very complex because we have a lot of different components in our cities related with the drainage of the water. For example, we have the surface, the roofs, and all the sewer network that is compounded by inlets, manholes, pipes, and outfalls. The importance of including this the sewer network is because the sewer conditionate or determines the time that the runoff spent in the surface of the city in terms of duration and in terms of extension. So, for example, we have two different scenarios. One scenario is when you the sorry, I know. One scenario is the normal condition operation when the system is not short-changed and the sewer network is able to drain all the surface runoff. Another operating scenario is the surcharge condition when the sewer network is not possible to drain the surface runoff and spill off over the surface. So for this, it's important to have a 2D, 1D dual drainage model in order to consider the interaction between the sewer network and the runoff model. For that, we couple IBER and the engine of swing in order to have a free distribution, two-dimensional, one-dimensional, high resolution dual drainage model. In this context, we solve the surface flow using IBER, the one-dimensional sewer flow using swing, and we can compute the bidirectional flow exchange between the surface and the sewer network. Also, we have a specific modeling roof tools in order to compute how the roofs and how the buildings affects to the runoff of the city. And then we parallelize this via GPU in order to have speedups up to 200 times. And this is all the input data that we need in order to compute an urban drainage model. Okay, as you can see, we need obviously rainfall data as a geograph or raster, and also information of the terrain, a DTM model, the curve number, land uses, and also the information of the drainage networks in terms of manholes, outfalls, conduits, inlets, and roofs. So all this information is really complex and is really huge. So it's important to have tools that can manage and can pre-process this kind of information. It's not common in numerical tools, special tools that are related with hydraulic modeling that can manage this information. So we usually use to support our pre-process and our post-process GIS software. And this is the motivation of the IBERGIS tool where we integrate the capabilities focused on the urban drainage of IBER in the QGIS system. And we develop at this end IBERGIS. And that's a brief introduction. Sorry if you saw some noise behind me. I don't know what's happening. The floor is now for Namu in order to have a little demonstration about IBER.
Thank you, Esteban. So we can proceed with the demo. Namu, the floor is yours.
Thank you. I think I do have few slides. Okay. Sorry. Can you see my screen? Yes, I think so. Okay, so yes, as Esteban mentioned, the whole idea of connecting data, processing, and also the post-processing is really critical in when we do flood modeling projects. So the whole idea of IBERGIS is in this base foundation. So you have the rainfall as all the input parameters that you necessarily need with the GIS land use context. You run the hydraulic models, you have the results, and having results is not enough. You need to make proper decisions through those results. You need to portray your results in a better way. So this is what when IBERGIS comes into. when we talk about IBERGIS, as someone already mentioned, the 1D is done by EPA-SWIM and the 2D is done through IBER, and everything is connected within geo packages and everything is available in QGIS interface. To give you a quick glance of how the user interface looks like, it's just a picture. I would show you a live demo, of course, but you have a couple of buttons that helps you to input all the necessary input parameters, and then you run the model, you make the mesh, everything that can be done through QGIS. And also with the results, you can run the simulations in the backend. The IBER does the whole processing and you get the results actively at the same time in GIS interface. So you don't have to exit your QGIS just in order to run your simulations. You can run everything through one interface. And that's the whole idea of having IBERGIS plugin. The another thing you can do is you can also import the results in web. So as we know, like having these flood results, the risk maps, it's really important to convey these kind of information to the public. So these can also be done through integration. The whole thing about open source and open access is you can integrate as many softwares or as many platforms into one. So this where it helps you, like, so if you have a simulations run through IBERGIS, you can have the files of those, and then you can actively show how it's being run. So without further ado, let's go to the live demo. First, we need to know where to download IBERGIS, of course. So if you go to iberaula.es, then you have these thing in IBERGIS, and you just can download for free here. And then you just have to click few more buttons, and then finally you can download for Windows. And we have the first version that has been published. You have general information, the pre-processing, everything with a little bit of background. You do also have a file where you can have the general startup, a user start guide. It's prepared. We can share with you. So it just gives you what each button is, and then how you can run a model. And then after you have this, you just have to install in QGIS as any plugin you would do simply, and then you would see a IBERGIS IBER logo button, and then you just have to click on it, and then you create a geo package. As I said, the whole IBERGIS is done through connecting geo packages with the IBER inputs. So you can create a geo package to one. For the moment, I'm not going to create one, but as I only wanted to show you that it's a matter of just a simple 2 clicks, and then you create the geo package. And once you have that, you can create a QGIS project, because in the QGIS project, we have already preloaded styles, which helps you to visualize your layers better. And of course, the plugin will be updated as time goes on. You can update your geo package accordingly. So once you have that, we already have an example data that you can currently work on with the IBERGIS. So if you want to look at it after the webinar, you can for sure create an example, run the simulations by yourself, and see how it works. For the moment, I already did an example. So once you create an example project geo package and create the QGIS project, what you see is this network. It is not necessarily a real scenario. It is a hypothetical case just to show what the tool is capable of. So we have the in the layers, we have the input layers where we have the swim, the IBER, and the mesh. In the swim, you have all the necessary layers needed for your swim network. So junctions, dividers, outfalls, storage, anything you can possibly input in your urban drainage network, you can input from that. Not only that, you can also import an INP file. If you already have an INP file, you just need to import it, and then it takes everything, and then it stores everything in the correct place if your INP file is correctly configured. The next is the IBER group, where you have these inlets. The inlets are the surface gullies, I would say, that goes the surface runoff to the conduits that are connected. The hydrograph is the rainfall station. You can use as many as it. it uses Thiessen polygon method to distribute the rainfall. Correct me if I'm wrong, Esteban and Marcus, but yes. And then you can also input boundary conditions, so inlet and outlet. For that, the bridges, the culverts, everything necessary for your whole land use, you can do it. Inlets are the bigger inlet surfaces, because sometimes it's not just one manhole point, but also like surficial rectangular gullies. So those you can do it. One of the things that I would start explaining are the buttons. So we have a couple of buttons here. The one is for running the simulations, making the mesh, and so on, and inputting your stream input parameters and IBER parameters. And the next is that helps you to configure your whole parameters. So for example, as I showed you, this is for importing INP. It works perfectly, but if you want to from scratch the network, you can also do it. The boundary conditions, you can create as many boundary condition scenarios as possible. That helps you to analyze different areas, different boundary conditions. For example, if in one boundary conditions you want to put any different time series, then you can also work with that. So that is the work. And also you can save this to any mesh. So if you want to save to, if you have multiple mesh, so you can also create multiple mesh. As I mentioned, for boundary condition, you can have multiple ones. So you can save any boundary mesh to, any boundary conditions to any mesh. After that, we have this button to create the boundary condition. So if you just click on it, then it gives you the edge of the boundary, and then you can create the boundary conditions through it. If you look into the attribute table, then you can see what boundary condition type, which boundary condition scenarios. As I said, we can have multiple ones, and you can also choose which time series that you want to apply to the boundary. So if you want to put a discharge, like a flow or elevations in a boundary conditions, so you can also put through that time series. So how can you put that? You can put through this another button called non-visual object managers. So it's similar to what we had in GIS water in the webinars before. If you were there, might be a little bit familiar, but nonetheless, it's similar. You just have the curves for the pumps, the patterns for your discharges, the time series, and as in the rainfall, the boundary flow. For example, if I have to create a new one, so I can put elevations, flow, inflow hydrograph for orifice or rainfall or temperature, anything like that. And you can also have rasters rain. So if you have rainfall rasters, then you can also import. Everything has to be in the same folder as in the geo package. But if you have the rasters rain, then you can easily import those too. And then the other one we have is bridge. So if you want to, for say, add a bridge, you can do it. The similar, it gives you a profile. If you have a dam, then you can also include a dam. For example, I think I do have a dam here. So this is of course not correct. I need to change the top elevations and the lower elevations. But the idea for this bridge button is that you can include the bridge. So if you have piers in middle, that also helps to regulate the water more detailed. And for the next part of the buttons, it's pretty much intuitive and simple. So we have tried to make it as user-friendly as you can. For IBERGIS options, it's just basic project details and information, the name, descriptions. The swim options, as I said, everything runs for the urban drainage using the swim engine. So everything that you need to configure for the swim engine, that can be configured from here. You can see which results you want to have. For IBER options, it's the same. You can configure as much as you like. For the precipitation, you can say rain or hydrograph, or use the rasters. As I mentioned before, you can also include raster rainfalls. For the losses, you can use the curve number, as Esteban mentioned in his slides before, that the curve number is used, or you can also opt for no losses. And then here you have for the results, you can choose which results you want to. So depth, velocities, specific discharge, for elevations. You can also get the maximums ones. And also, interestingly, you can configure the resolutions of your results. So if you want to have the higher resolutions, then you can put the cell size less, and then if not, then more. The Eber plugin here says you can have the complete network. So if you have your drainage network and your hydrological parameters, then you can work with the complete network. If not, you don't have your network yet and you just want to see the surface flow for the moment, while you are still configuring your network, you can use only inlets. And then we have certain checks that you can do, and everything can be configured as you like, and it just gives you the whole the credibility of your input parameters. So if you want to check, because sometimes there's just few things that might have messed our eyes, so this could help you make your input parameters better. And then we also have the options for symbology. So we love maps, of course, we love colors, and this will help you to make it better. So these are just the buttons that help you to work with IBERGIS. So now next we can see what inputs do we have. So for the inputs, there are two major ones, the ground and the roof. The grounds are the grounds where you walk on, where you drive, everything, the grounds. The roofs are the representations of the buildings. So it's like the actual buildings, apartments, everything. And then with this, in the ground, you can have multiple land use categories. So for that, for the first, you need to configure your land use categories. So what land use categories you have. For the example, we just have 3, but of course, there will be much more than 3 for the land use. After that, for the ground, you can also have custom roughness or like the curve number and the cell size. You can put cell size as you like. For the moment, I've just put it to 1. You can also add, so there are 2 ways to have the grounds. One, you can draw it by yourself, but there will be too many grounds, and who would want to do that manual labor? So we have a couple of sets of algorithms in processing toolbox in QGIS itself, which will help you to make your life easier to import these informations. So you can have input ground geometries, input roof geometries, input inlet geometries, everything that you need to work on, you can have that. But also when you make the mesh, there are certain validations that needs to be done so that your ground layers and the roof layer are true, the coverage is valid, there are no intersection layers, intersection parts having present. So these kind of things, everything is help through all these processing toolbox algorithms, and you can run if there are any closed vertices, or like you can create a temporal mesh, to see, for example, you have a roof and everything, then you can run and see how your mesh is being formed. So of course, when I share the screen, it's a little bit delayed, but it's really fast, as I have to say. The next is for the roofs, you have the slope, you have the width. The width is calculated as per what Eber demands. So we have this paper, you can use this paper to do it, but it's basically the area divided by aspect ratio square root. So this is what you can use for the width. And then yes, here we go. And then if it's connected or not, the outlet codes, if the roof is connected to any outlets of the swim network to pass the water to the network, you can have this one, and the cell size, of course. So these are basic informations that you need to input for the roofs. And after that, you can create the mesh. So how do we create the mesh? You just have this button called Mesh Manager. And as I said before, you can create as many mesh as you like. Not just that, if you just want to select some part of your network, or sorry, some part of your area, then you can also select features and just create a mesh of that area. And then using these specific requirements, you can apply the boundary conditions. That is the current scenario. You can choose the elevation dem layer. You can have a raster layer, so not just in the layer itself in the columns. You can also have a raster layer of the roughness and extract the roughness from that raster layer. And similar to that, you can have the curve number. You can give the mesh, and then you can create a mesh. So you have the elements, the creation date, everything pretty basic. You can also export the mesh as 2DM to see in QGIS itself in 3D. It is not the best visualization because QGIS is still focusing on advancing that, but you can also work on that. You can export as rasters to see how it forms. You can also export as IBER format. So if you have IBER separately downloaded, you can also export that. Not just that, you can also import some mesh if you have. And you can delete, of course, if you don't like it. And then what else? There are these thing called mesh anchor points and mesh anchor lines. What are these? So usually when we have the digital elevation elevation raster layer, not necessarily it represents the true reality, and we might have to twitch a little bit the DEM. So in that case, these anchor points and mesh anchor lines helps you. Not just that, I would say if you want to, if you simulate a flood and then you see, okay, there is some flood happening and you want to have a wall per se, you can introduce an anchor line with the elevation and the details of how much height the wall needs to be. Then you can see in the mesh that it has been changed, and you can see how it works with the actual. So it's kind of like post-processing, but also seeing if your mitigations works too. And what else can we have? There are certain things, algorithms like inlet to junction. So everything with the inlets, we can see which junction is it connected to. So that's how you can see. You don't have to do it manually. You can do it manually if you want to, but if why to make our life harder with that, you can just use ArcGIS processing toolbox to work with that. And finally, the most awaited thing, you can run a simulation. So running a simulations is pretty simple. You just have to click on this run. Pretty much basic in every modeling tools. You have this run play button, and then you have the options. As I said before, the options is similar to whatever is needed in SWIM and IBER. So once you have that, you accept, and then you can click the mesh. So the beauty of having different mesh and different scenarios of the boundary conditions is you can select any mesh that you want to run as simulations. After that, you select a folder because all these it creates a set of files and folders that is necessary for IBER to run in the backend. So you can do that. Let me give you a quick glance of how it looks like. So for example, if I do demo trial, I click the mesh. So it says like, okay, export files. It is writing everything for the SWIM. It is running the IBER software. So everything is done is within the QGIS interface. You don't have to like close the interface and then run the IBER again. And if you say what could be the difference, there is no difference at all. It's the same software that has been executing. And then if you have GPU, then good for you because it will work fast. If not, also it's pretty fast. So as you can see for the mesh and the simulation time is pretty fast. And might I add, I have been working on real projects, and we have projects with more than 2 million of mesh elements, and I've been running simulations for more than 3 hours of simulation time, and it runs within 30 minutes. So that is pretty good for a simulation. And then after you have that simulations run, you can have automatically the simulations results in your GIS interface. So it just takes a couple of minutes, but of course, since I'm sharing my screen, it lags a little bit, but if I'm not, then it's like a couple of minutes, 1 or 2 minutes stops for the example project to run. But I do already have a result, so I can show you. So each layers is a time series layer, and then you can have these temporal controller, and you can see how the water is flowing in your system. So as I said before, in the IBER options, you have multiple options of results that you can import: depth, elevation, specific discharge, rain depth, velocity. So for the moment, I have depth, elevation, infiltration depth, all these things. I would say the most interesting for anyone, for us, the water engineers, would be the depth and the velocity. So you can look into the results of how the water has been flowing in the systems, how it is evolving. So these kind of results can be seen. And as I said, the whole idea of integration is that you can have these results in the web too. So once you have these results here, you can also export to your web. So you can have multiple simulations as you like. As I said before, you can have multiple scenarios of boundary conditions, multiple cases of mesh. You can just select one portion of your area to create a mesh and just run simulations out of it. I have to add that EBER works with distributed modeling, hydraulic modeling. So yes, you have to take consideration of what your boundary conditions need to be, how much area you need to integrate for your area. But that basically sums up. Also, if you have, for say, results that the other person has run, and then you just want to import in your QGIS, then you can just load raster layers, and not just the surface flow. Might I add, you can also see the flow in the profile. So if I click on the nodes of swim and the final node, let's say, you can see the profile of the swim network too. So you can draw the profile. Oops. You have to make sure the time is the same. If I'm correct, it's 17:01:01. 01:01. Yeah, I don't know why we put this as 2017 while the plugin has been recently made, but nonetheless, let's see. 0, 0, 0, and then if we put 03, okay, oops. So you can see here if you have, so how you can see in your stream too. So this is amazing. You can see in your line in the surface, not just that, you can see in your stream networks as well. You can also add your vector results. So if you have the vector results, so if you noticed, it's pretty much same what we did in GIS water before. In the demo, you have the floodings here, here. So you can now see the results and try to analyze whether it makes sense for you or not with the surface flow and the 1D flow. So this is what you can do with IBERGIS. And you can also have the report summary, the same as what you get with the swim. So everything that you can have, the results from the input to the result, from the options to simulations parameters for both IBER and for swim, you can have everything in QGIS. So this is one of the ideas of having IBERGIS, and I've been working in real projects, and it has been working pretty great. Of course, you would have a lot of questions, so I would invite you to like join the Mentimeter in the chat box and also like put questions. For the demo, I think that's all. Thank you.
Thank you, Namu. So overall, very complex tool, lots of content, a bit difficult to summarize everything with these few minutes. But the idea here, I think it's pretty clear. We can start from nothing. We can start from a corporate IMP that's calibrated and then work on the mesh. We can start from an existing mesh that we have developed with IBER and then add the IMP. If we have both, then we can mix them together. So it is a bit modular. It's a bit oriented so that you can start with whatever you have and you can slowly but steadily start working towards the end goal. And we have a few questions. If you want to put more questions in the Mentimeter, I think it should be an option. Yeah, I'm not sharing the screen, sorry. So as we can see, these are the questions. And in fact, I think there was another question, but it doesn't appear here. And for some reason, I cannot see it. So we will start with these ones. First one, how long might it take to set up a basic model like the one we saw in the demo? Maybe Namu, you want to answer that one?
Yes, for the swim network, I would say, like, how long would you need to validate in the SIM network for a basic municipality for the SIM? I don't think it's that hard. And also, what I personally do is work with GIS Water. So GIS Water helps a lot with configuring your network in the easiest possible way, and you have a lot of like tools that helps inside GIS Water to make your network intact. So that's that. I would say for simple demo, half a day with GIS Water. And then for the lanyards, just this area as it is given. It depends on the quality of data that you have and the available sources. So if you can have public sources as we have in here in Spain, all the open sources, the land use, everything, also half a day, not too much for that one. But yes, of course, if you are working with like corporate municipality, you want everything to be intact. So you might have to do a lot more checks. So it might take a little bit more time. But yes, to just set up this one, maximum 2 days stops from scratch.
Great. Next question. Is prior experience with stormwater management model or IBER necessary to use IBERGIS? Maybe Esteban, you want to answer that one?
I believe that yes, is needed because swing and IBER numerical models are physics-based, so has a lot of parametrization, have a lot of methods. So it's important to know how each model it can run but independently. So I believe that always is necessary to know a little of these two models. Then obviously is necessary to also to understand all the IBERGIS workflow. Yes.
Thank you. Now, next question. How is the exchange of flows between surface and network managed? Is it automatic or does it need to be configured manually? This one, we will shoot Marcos.
I can answer that. I think Esteban is the man who developed this. I think it's better to answer him.
Of course. Then Esteban, your turn again.
Yes. It's completely coupled, so it's dynamically, so you don't need to configure manually nothing. The both models run in a coupled way, so the exchange is carried out using the wear and orifice equation when you are introducing a runoff inside the sewer, and in the opposite direction when the manholes overflow, it's like a source in the street. So then the IBER propagates this spill flow inside the two-dimensional domain. So it's fully coupled. So the user only need to put the wear and orifice coefficients in order to try to calibrate a little the two parameter side this process. But both models run completely coupled.
So as you can see, Esteban already did a lot of work for all of you. We don't need to worry about these things. It's already solved. Next question. Which factors have the greatest influence on simulation time? Maybe you want to tackle this one, Marcos, or do you want to pass it to somebody else?
No, I can answer. I can answer. The key factor is the element size and also the velocity and depth, because either is a finite volume method based explicitly in time, so it needs to solve to solve no to accomplish the current conditions. So this is the two main things that you have to take into account when you do any simulation with these kind of models.
Thank you. Now, next question for Namo. Last week we presented GIS Water, and this week we are presenting IBERGIS. Is it possible to integrate both tools?
Yes, of course. I mean, as we said before, like we can have uh, GIS. From GIS, you can have all the network ready, and through GIS itself, you have the possibility to import the geo packets that you created through IBERGIS. So all you need is you need to have both plugins installed in a QGIS interface, and if you have both installed, then you have imported the geo packet from the IBERGIS that you created in the GIS water systems. And if you have all your network configured, it works pretty much basically the same. You have the options. I'm not sure if a lot of people were in the webinar, so we had the option to do go to EPA. So you run the simulation through GIS Water, and you have the same option like go to IBER, and then it just runs the simulations. And everything is same with the options and swim options that I showed you before.
Thank you. So next question. This is half answered, but we will do it anyways. Unlike SWIM, where the runoff comes in the system through manholes, in IBERGIS are the inlets in elements through the run are the inlets in the elements through the runoff comes in. So Esteban, maybe you want to go to this one as well.
Yes, at this moment, the runoff can enter through the sewer network only through inlets, via inlets. Also, via roofs using another equations, but not the entrance of water via manholes is not allowed now. You must put an inlet near the manhole to consider that a manhole can be a hybrid between manhole and an inlet. Yes.
Thank you. Next question. Does this allow the evaluation of measures such as sustainable urban drainage systems or stormwater tanks? Marcos, maybe? Esteban? Any volunteers?
Not at this moment, but we are working on
Future implementations. Great.
exactly.
And last question that we have here, is it possible to use other runoff functions like green amp? Whoever wants to answer.
It's not yet implemented. In fact, for urban drainage, this infiltration model is quite complex to use it. So the hydrological processes in an urban drainage, in a urban drainage zone, is very simple, and we can simulate with the curve number. But other methods are already implemented into IBER and probably will be implemented in GIS.
Thank you, Marcos. And I think we have some questions in the chat. Let me check. Yes. Do you consider the options to work with the GIS water database instead of a geo package for the ones that already use GIS water? I don't know who to pass this question to. So
I can answer. So the whole idea of working with the database is multiple people can work at the same time with the PostgreSQL as we do in GIS Water. And of course, with GeoPackage, it's not so user-friendly if a lot of people are working in the same project. So this is one of the next steps that we would like to do, of course, to make certain things faster with the database than GeoPackages, of course. So yes, this is the next step we will be working on to transfer everything to databases instead of working with your packages for IBERGIS. It will be much faster while reading and getting the inputs and the outputs from the database.
Thank you, Namu. And here we have Rengifo. Sorry if I mispronounced the name. We already answered this in the beginning. So just so you know, if you joined late, I believe we will have the recording published on YouTube. I'm not 100% sure, but I think that's the intention. Does anybody want to re-answer the question of whether it's going to be accessible for Linux?
Yeah, we have an Iber version of Iber, a version of Iber in Linux, but at this moment, not IBERGIS in Linux. If it's exactly the question, no, only Iber, not IBERGIS, GIS.
All right. Could it be possible that the teacher, I assume the teacher may surely explain the model validation when we run the simulation? Who is the teacher? Sorry. Maybe Namu who did the demonstration?
I think he's talking about the model validations after we run the simulation. Of course, we don't have automatic validation technique in the IBERGIS. So if you want to validate your model through the simulations, you need to have pre-observed data that you can align with your plot extents and stuff. I think that's basically how in normal slot modeling we do. If you have any more ideas, maybe Esteban and Marcos.
Only just a clarification because the model itself, the computational engine is already validated, is the PhD thesis of Esteban. So if you are looking for a validation of your particular case, you just as Namu said, you need observed data to check if your model, the results of your model are similar than your observation data. This is the idea, more or less.
Yes, I think the key part is having your input parameters as best as possible according to the reality. And if you have it and you have your observed data, you can pretty much align. Like I have done model validations with certain areas where I have the flood extents of certain years and I use the certain years rainfall and simulated, and it is pretty much the similar. Having said that, you need to have your input parameters correct. As long as you have your input parameters correct and viable, then your simulations are likely to be validated truly.
Great. We have, I believe, the last two questions. Is it possible to import the results of the database to GIS Water right now? Namu, maybe you want to answer?
Um, yes, as I said, we can connect most of the interfaces. So if you want to have the Azure packages imported in the GIS Water database, then you can run the simulations with your network, urban drainage network configured in GIS Water, and then you have the results as similar. Although we do have to like work on the styles and everything, it is not exactly similar to IBERGIS. It is much more because you also have the urban drainage. But yes, of course you can.
And how would it be possible to take into account the surface of the groove of the gully if it has one? This is very detailed
Yes.
question.
In that case, as I quickly mentioned, if you remember, there is thing called P inlets. So we have those P inlets like an area, not just a point to have the gully. So that takes into account the area if you are asking about that one.
Well, great. Thank you to our speakers. Thank you to all our listeners for coming here and for being interested in this tool. Of course, you have the opportunity to try it by yourself and you have the opportunity to ask any further questions. And I believe the recording will be published on YouTube. So
Thank you all for coming.
We have the last slide if you want to answer if it was a useful and productive session for you.
Yes, also I would like to add 1 hour is not enough to show what IBERGIS is capable of, to understand what it can actually do. So if you want to learn more, just keep following us. There will be a course hopefully soon in IBER Aula. So if you want to learn about IBER, as Esteban said, you need to know the basic concepts of IBER and SWIM. You can go to IBER Aula, see the courses, and IBERGIS courses will also be there as soon as possible as we can. Nonetheless, we do have these series of IBERGIS, so where we put like short clips of how you can start with IBERGIS plugin, so you can also work there. And if you are really keen on, and if you want to add more to the tool, of course, you can contact with us.
Well, thank you, everyone. Have a nice afternoon or morning or wherever you are. Have a nice day. Goodbye.
Bye.
Okay, goodbye.